All right, so looking at today's lesson, and like I said, it's going to be really basic. Joe, you brought it up perfectly, right? What's a ray? What's an angle bisector? What's a perpendicular bisector? What does all that mean? Yeah. And that's what we're going to talk about today. And that's why it's a really good intro. It basically forms the foundations of all of our lessons that we talked about in this class. So first thing we're looking at our objectives today. As you can see, they're really difficult objectives. Basically, tell me the difference between a line, a ray, and a segment. We're going to learn how to label those correctly. And then the most important thing, this is the thing I think really just drives me crazy, that as high school students, the number of you who don't know the difference between finding the perimeter of a box and finding the area of the box. It saddens me. Truly saddens me. So we're going to try and focus on that today. Drive that one home again. Area versus perimeter. And what that means. What that means geometrically. What that means in the real world. Okay, so it's really not that bad. So first thing we need to talk about is what is a point. I want you guys to tell me, what is a good definition for a point? Go ahead, Casey.
It's a spot where the line begins, about where the line ends, and or it's a spot in the line which is by the middle or any spot.
So here's what I got here. Spot. Perfect. And basically, points make up everything else. So we're going to talk a little bit about, we'll dive into theory here for a minute. Another good way to think about a point is think of it as a singularity. Singularity. Now what that means is I want you to close your eyes for a moment, and I want you to think about a point. Try to envision what a point looks like. And now I want you to make that point smaller. Take the smaller point. Make it smaller. And make it even smaller. And smaller, and smaller, and smaller, and smaller. A point is infinitesimally small. It has no dimensions whatsoever. It has no depth. It has no length. It has no width. It simply is there. Out in space, 3D space, there's this point. And it's infinitely small. That's what a point is. Now, obviously, a lot of times in geometry, we basically say, here's a point. And a lot of times when you watch me make drawings up here on the board, if the lines don't intersect where they're supposed to, we just make the dot bigger. Yeah. So points are kind of fluid. They can get big and small, as long as we understand what the point means. So that really is just a singular. Okay, so we have 0D. No dimensions. 0D. Forget 3D and 2D. This is 0D. All the D you need. Ha 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 ha. All right. Now, a line. What is a line?
It's a line.
A line has 2 points.
What's the line? All right. So it connects 2 points, right? That's pretty simple. All a line does is it connects 2 points. It's a geometric figure that goes from one point to another. Point A to point B. That's it. That's all a line is. Simple. How many dimensions does a line have? 1 dimension. And what is that dimension? Length. Right? So a line is infinitely thin. It's basically about as thin as your pencil or pen can make it. But again, you need it when you're drawing these out and you're looking at figures, you need to again think this. So that's a line. How many points make up a line?
It's a line's never ending. So
Okay.
it's just until I end.
So what's the minimum number of points you need to make a line? 2. So how many points make up a line?
Two or more.
Hold on. Yeah, I need to ask you guys, in this world of the pixel age, you guys being supposed to be technology natives, which very few of you are, pixels. think about that. What is a pixel?
Really tiny.
Well, what is it?
It's
It's
little.
a
It makes
No,
the
it doesn't.
pictures.
What does a pixel? A pixel do?
a small area of storage.
And what does it do?
It makes something.
Stores what?
That,
Memory.
And how is that memory displayed?
Throughout.
In a color. One of three colors, right? Red, green, or blue. And then since we've now gone up to 256 megs, we can now have up to a whole bunch of colors, right? We can get variations almost within a single pixel. Okay? Let's do some old art. Here's some art history for you. Pointillism. You guys know what I'm talking about?
No.
Wow.
Yep. No. Okay.
Pointillism. It's a type of art. Who wants to explain it? Go ahead, Casey.
I'm gonna try it. It's like when you start out with a single point and then you just add on to it.
Add on to the point.
Like you add multiple points to it, but then you add on to the single point that you started out with.
Yes. Hey, Brandon, you have something to share with that? Perfect. Okay, it's basically a whole bunch of small little dots. It's just how many got your comic books? Okay, a whole bunch of little dots, right? If you look really closely, it's just this array of dots. But when you step back from that array, what do you see? You see a whole picture. With the pointillism painting, you step back and you see this whole picture. If you get really, really close to that painting, you can see that each individual dot that the artist puts on there. And each dot is a single color, which then adds this beautiful depth to it. Our computers and TVs run the same way. A single pixel. When I walk up here very closely, I can actually see each individual pixel coming out of the projector. And each pixel has a specific color associated with it. So while I'm really close, I can see each one, but when I step back, I see the entire image. A line is very similar to that. When we see a line, all a line is the whole bunch of little dots. If you were to zoom in closer and closer and closer, you start to see these dots pop out. But when we look at it from far away, we see it as a single continuous line. Okay, so that's another way of looking at a line. It's actually just a series of points that actually make up the line. Okay, so it's an infinite number of points that make a line. All right, someone define for me in your own words a plane. I'm not talking about the ones that fly. I'm talking about a geometric plane. Dang it. Make sure we press it off. All right, come on, guys. What's a plane? Well, you guys have done this before. This is like third grade math. What's a plane?
No, not that one.
I have a grid plane.
Well, that's a type of plane. Yeah.
Big area where you control all your geometry.
Okay. So what makes something a plane?
The square shape. Is it like a graph?
Well, that's how we get the Cartesian plane, is from this definition of a geometric plane. Okay, someone tell me, at least in the room, where can I find an example of a plane? No, in the room. On the board. Why is that a plane, Brandon? Because they have two lines that never end. Kind of, you're really close, Brandon. I'm impressed. Guys, all a plane is, it's a flat surface, a flat continuous surface.
Oh, yeah.
That's all a plane is. And it extends infinitely, supposedly. Now, here's the funny part about high school geometry. Everything we do in here is going to be two-dimensional plane. Right to the end where we do three-dimensional shapes. However, there's a slight problem with that. What world do we live in? Three-dimensional. And not only that, but we don't live on a plane, we live on a sphere. Which means planar geometry cannot exist on the sphere. And weird things happen when we get into spheres. Triangles start to equal 1 at 180 degrees. You have to right. It's just weird. Parallel lines intersect. It's just all kinds of weird stuff. No, it's so cool. We'll talk about that later. All right, so plane. I know. Keep up. All Alright, so plane is basically flat. Continuous. And that's basically it. It's just flat and continuous. And by the way, so how many dimensions is that? 2 dimensions. Length and width. Almost. No,
10 years from
40s.
10 years from now.
No 40s. Okay, now here's the question. How many points does it take to make a line? So how many lines does it take to make a plane?
Wait, say that again?
How many lines does it take to make a plane?
Flat
Well, here's one line. Does that make a plane?
No.
Two.
So you need to have at least
Two.
2 lines. And if I have my 2 lines, I now have the infinite plane in between them.
Yay, with the custom grades.
When you get into college mathematics, we call that the cross product.
Just a little bit of football. I know, but
It's a little here, a little
this is the
here.
one thing I don't want to think of.
All right. So, by the way, then, so how many points does it take to make a plane? 3 points. Because when the lines intersect, it's a shared point. So that's actually 3 points to make a plane.
Page 2. 3.
Okay. So any questions on those definitions? A point, a line, or a plane? All right. Now this was back to Joe's question earlier. Different types of lines, right? You have a line, you have a segment, and you have a ray. Why are we even different?